Okay, we're going to roll into some transducer faults. We're just going to look at some, kind of more focus on some of the more visual types of damage that you would see, a bit more obvious. And, these specific, types of failures are not necessarily on the machine. So we're going to focus on that, and then we'll move on to the operational failures a little later on in the presentation. This is an example of a lens failure on a transducer. As you can see, this is pretty severe. Again, I have a transducer here to show you, and on this particular probe, it's a red lens. But these are vulnerable to holes, scratches, peeling back, cuts, whatever have you, to this really rubber lens that is in between the patient and the crystal that sends and receives that sound. And generally, this is caused by just use of the transducer and maybe some accidental damage. From our experience in repairing a lot of transducers, oftentimes improper storage. We've seen them in bins to where they kind of rock around, and especially during transport, they bang against things that are also in that bin. They're dropped or heavy impact. That can actually, when they're dropped, the edge between the hard plastic housing and the lens can actually separate a little bit, and you wouldn't see it right away, but then the continued use of gel, and when you put gel on these, the gel being water-based will start soaking in there, and it will start to actually break down all of the adhesives that are inside the transducer. And also cuts. These are used in the healthcare environment, and they're around sharp things. So they could get cut on the lens. And again, when you apply gel to this transducer, it'll start getting in there and really eroding away from all the adhesive properties of the lens itself. And in this particular case, being pretty severe, we have this you see here as I'm circling it. The gray matter is actually the top of the crystal. And so you can see sometimes when the lens damage is so severe that the crystal is actually breaking away and adhering to the lens that's separating, and this is going to cause some massive problems in your image quality. So take care of the lens. It's the most important part. It protects the patient from electrical shock as well. It is an insulator between all of the electronics in the probe, and it keeps it away from the patient. And very common issue. If you catch it early, the repairability is way high. But if you let it sit for a while, corrosion sets in, and the damage just becomes much more severe as time passes on. What we have here is some issues around stain, strain reliefs, and cords of transducers. So if I have a transducer here, we're talking kind of the strain relief that is between the cable itself and the body of the probe, and even the cord sheath, which is the cable here on the outside. What we want to chat about was, there's a lot of chemicals used to disinfect these transducers after a use on a patient to get ready for the next one. And sometimes they can stain these rubbers that are on the probe here. And it's very repairable. This is something that doesn't really impact performance or patient safety. It's a cosmetic issue and very repairable, and something that sonographers really pay attention to, because that's patients come in, and if they see a probe that looks dirty, they start asking questions. And so this is something just for you to look out for. If you can catch it before the sonographer does, then you're just preventing a weird conversation later. And again, a very common issue and something that is easily addressed. On this transducer failure we're looking at is really a cut or a crease cord. And so we have a transducer, and we're talking about the cord here. And in this particular example, we got a picture of some cuts, and the lower picture here is a crease. And pretty straightforward. The cuts is something sharp got to it. Could be a surgical tool, could be accidentally hitting something hard and sharp. And the lower one, not really a cut, but a pretty severe crease here is, oftentimes pinched in a door, run over by a machine, something like that. And the reason we want to call this to your attention is because while the superficial damage may not puncture all the way through the protective layer of the cord, it's all the micro wires inside that, that rubber covering. The wires are 42 gauge to 44 gauge coaxial wires, and there's over 100 of them in there. And so with that kind of cut that could actually possibly cut the wires on the inside, going to give you a ton of image quality issues, likely dropouts, at least some noise in color or CW. The same thing can happen if it's just run over by a machine or accidentally, get into a door jam and it gets, kind of pinched off and it crushes all the wires together. So now you have all these wires that are crushed together and creased. When you see a crease, that will cause chafing and unnecessary shorting between all the microcoaxial wires on the inside. So, this is just something to really look at, because that's a very possible cause to where you have image quality issues. To look at that cord to see if you can see if there's any evidence on where that noise could be coming from, and a great point to train and help educate sonographers to get the cables up off of the ground when you're moving a machine. When you roll them around, the cables do drag on the ground. So those wheels, these ultrasound machines weigh hundreds of pounds, and 100-pound, hundreds of pounds machine against 42 gauge wires, the 42 gauge wires are going to lose every single time. So something here that could be nothing and could be superficial, but again, we have seen on a many occasion that this is the source of a lot of image quality failures by virtue of the lines shorting together or just breaking altogether. Another common failure for transducers is the cord is separating from the strain relief. So we're talking about, the strain relief of the transducer that's attached to the cord here. This is compromised and it's now separated from the two, exposing the internal electronics. Same thing on the other side of the connector, that we have the strain relief here, the cord, and it could be separated here too. Now, how does this happen? This happens when the cords are really pulled on pretty hard. Specifically, this is getting tension over time that has exceeded the grip strength and the adhesives here that break down over time. And the main problem here is not only is the probe now kind of the outer protective layer is separated, like you see in the picture here on the top and the bottom, it now exposes all the electronics to the external world. And when we're looking at protecting the electronics, this is a huge compromise to all those microcoaxial lines on the inside. We are exposing the braided metal that kind of keeps things together, but it also acts as a ground. And on top of that, you can see on the top picture here that right here, that isn't shiny metal. That's actually, over time, this hasn't been addressed, and now there's corrosion taking place, likely from some gel getting on there. And now once corrosion starts, if you don't completely get rid of it, it will continue to propagate, even if some things are covered up. If we put that back together, that metal will continue to corrode on the inside, and that has to be all properly cleaned out, and the probe has to be disassembled to do that. And so this is something that likely is a very straightforward repair for you. Companies like us, we can do that. We basically get the cord sheath back in there and use the proper adhesives to keep it there like it should be. But if you see this, remove it from service immediately, because this can be a very simple and straightforward repair, and over the course of a day or two can turn into something of bit of a mess because the wires here and the grounding is all exposed, and now it's extraordinarily vulnerable to other damage. So we highly recommend if you see this, if your sonographer sees this, get this into service as quickly as possible so it can get rectified, and a very inexpensive and quick repair will avoid possibly a catastrophic failure in the future for you. This transducer failure, this is just a pictorial representation of burnt connector pins. So if you look at the connector here, there's pins, and this will plug into the ultrasound machine, and that's really where is the interconnect between the system and the transducer. And here, a pretty big deal. You have actual transducer burnt connectors here, and here I just circled in red. What is likely to happen here is we've seen that some light fluid, typically a little bit of gel on accident, maybe some cleaner that accidentally got on the electronics of the probes here. Don't use fluids on this part of the transducer to decontaminate them. Very bad idea. It can cause these kinds of things, but what happens is that there's a spark and there's an arc here, and we commonly see it when there's a little bit of fluid there, and bam, we got that fluid will be right across two pins right here. Here's multiple pins actually, and those two pins will short. Now, when they short, it can be something as simple as just a repair that would replace the connector of this transducer. That's on the really optimistic side. But again, these circuits shoot all the way down to the crystal, and this can actually blow up the crystal on the other end. And so, this is something to keep an eye out for, keeping these things dry. Another one is, there was just a loose connector onto the port. Can cause this too, where the pins are close enough and happens. That doesn't happen very often. We typically see more of it around just some, unnecessary fluid sitting there on the transducer, and this can wreak havoc. So this can become a real issue really quickly, because not only is the probe damaged, this could actually damage the machine as well, because when that shorting, that circuit shorted together with the probe and the machine working together, and they're connected. Those two circuits are connected, not only the probe side, but now the system side as well. So highly recommend that if you see this, immediately go check the ports on the ultrasound machine to see if anything's going on there. This will absolutely cause catastrophic errors. It will cause noise. It'll cause anything under the sun that a probe can throw for an error, or a machine. And so to kind of reiterate, you gotta check the system too here and make sure that that's okay. But again, I think just some education to the sonographers. Make sure those connectors and electronics are all dry. Don't put anything wet on them. It can be accidental sometimes. Actually, most of the time it's accidental. Nobody tries to put water in here, but hey, it happens. I mean, you got gel, and that's just a common practice, is you have to use gel to scan, and things happen. And so when you see this, your red flag should be going up right away to go check that system as well, and make sure that there's no burnt pins on the other side. This slide's about bite marks and scratches, specifically on a TE. So when this goes down the esophagus, you can see in the pictures here that there's a lot of scrapes and scuffs, and can become an issue if those are severe enough to expose the internal electronics to the patient, to soaking fluids to decontaminate these probes, causing shorts internally because the fluid will get into the transducer. But how does this occur? Well, first and foremost, here's a T probe, and the lack of a bite guard is a common issue. The bite guards, really go into the patient's mouth. It's a protective layer between the teeth and the transducer itself. What the bite guard does really well is it protects the T-probe and the patient from the T-probe on the front teeth. But the back molars are still an issue. And what we often see is that, these probes, there's these locking mechanisms here. So you can actually rotate this probe all the way forward and lock it. And you can see now it's in a lock position. So imagine this is actually inside a patient getting a wonderful scan of the heart, but when the procedure is done, this isn't unlocked, and now this is in a forced position to come out and drag against the back of the molars and causing those kind of deep scratches. We highly recommend just release the probe, get it straight, and then pull it out, and that will prevent a lot of this deep bite mark and scuffing damage. Where it becomes really an issue is if we look at the lens here. I'm circling this in yellow and red to be a little more visually acceptable. That is, if you start scratching against that lens, now you're actually putting impact and pressure on the crystal itself, this most sensitive part of the probe. So you want to make sure that to protect the probe and probably cause a little less discomfort for the patient, release the mechanism that locks the probe into place, and then go ahead and remove it from the patient. This can cause some really severe failures in the future. It could actually, the little RTV here that I'm going to circle on the left hand side, the edges of that can start to get chunked out and then exposes the next patient to fluid intrusion. Right, so there's electrical shock safety issue, and then number two, imagine it's sitting inside of the sterilization fluid for 20 or 30 minutes. It will actually get in there and begin corroding the crystal itself. So really important, really basic educational, super simple to communicate to all the users of the probe. Go ahead and release that locking mechanism and then take care of that probe as you're pulling it out of the patient. So continuing on with the T-probe, this is just really a better pictorial representation of the seal kind of being degraded. You can see on one side here on this probe, but as you kind of trace around the edge, you can see the corrosion that's occurred, and then just the RTV just comes off. It loses its adhesive properties. It's acidic no matter where it's living. When it's getting decontaminated, it's in acidic and caustic fluid. When it's inside the esophagus, there's all that stomach acid, and so you can see that circling down here, just the RTV starts to degrade and break down over time. And it's very repairable. We can seal that back up. But the major concern is not the seal itself failing. It's the opportunity for any fluid, whether it be stomach acid or sterilization fluid, getting inside the electronics, causing corrosion. Corrosion's a big deal in probes. Once something starts to corrode, you have a window of time to be able to catch that and make the repairs and clean it up. If it's over a longer period of time and it's not caught, what happens is that the materials of the crystal just break down. There's nothing to repair anymore. It literally just disintegrates. So the earlier you can catch these failures, the longer life you're going to be able to have with these probes by catching it early, getting it repaired, and a repair price is far less expensive than a full replacement if you leave it too long. So again, just something that you can educate sonographers, technicians, your sterilization department especially, is to look for all these types of things as standard protocol. And if you do identify it, get it to repair as quickly as you can. We can help you with same-day evaluations. This is a very straightforward repair if there's no imaging issues, and you can extend the life of that probe with a very simple repair process. Here we have a couple of very close-up pictures of some punctures in the bending rubber of a T-probe. Pretty common. The bending rubber, again, is the section from here below the tip to the insertion tube. And what that allows the probe to do is it allows to, move in any direction for a user to manipulate the probe to get a perfect image of the heart. And now these pictures are taken under high magnification. These are very small, and we really recommend that the sterilization department have a nice magnifying glass with good light to be able to inspect the bending rubber and the tip too for any damage. Now, as you can see, these are very small holes, like pin needle. These are caused likely by instruments during the procedure that are very sharp and oftentimes not really visible on a casual glance of the transducer. So a magnifying glass is really important with some good light. And what's important here is that these can falsely pass a leakage test. And the reason being is that if you actually bend and articulate this transducer forward, if the hole was on the front of this where it's bending, it would now be closed, right? If the hole was over here, it may be stretched out and it could be exposed more. But if there was a hole that was on the outside edge here during a procedure, and now you straighten it back out, that puncture was just now pushed back together. And when you put the probe into a leakage tester straight like this, that hole is now sealed by virtue of just straightening the tip. And so we recommend that the sterilization department really look and bend it and just really articulate the bending rubber section to give a really close eye underneath a magnifying glass to catch this. Early detection here is really important. Oftentimes here, if there's some fluid ingress, it's not catastrophic, very repairable. And if you catch it really early, we can take it apart very quickly, replace the bending rubber with a new one, and clean out all of the acidic fluids on the inside to prevent the corrosion. And for a very inexpensive repair, you just save the probe and really extended the life. The danger here is that if it's not caught early, well, T-probes are stored upside down like this, straight, so the insertion tube doesn't curl and assume a curled position. So if you look at how gravity works, all the fluid that would be entering from a micropuncture in the bending rubber now will fall right to the crystal. So highly recommend that catch it early, get it repaired early, and you can avoid a really costly replacement on these T-probes. So we've been talking about fluid ingress into T-probes, and here's just a couple of examples of fluid getting inside and running up and down the probe, depending on how it's stored. Let's start with the bottom. We opened up this bending rubber here, and you can see that this had some pretty catastrophic fluid ingress, and there's just it literally is just spewing out of this bending rubber. So those punctures, there's a lot of fluid that can get in there. It doesn't seem like much, but just one drop here, that will cover dozens of circuits and short them all together all at once. And same thing here. This is the connector of a T-probe, and the connector would be this portion with the controls. The fluid would get in, and then on the tip or the bending rubber, and it would actually slide all the way down and drip into the handle. Or the handle wasn't properly sealed and it accidentally got dunked in some water or whatever fluid is being used to clean these probes. But as you can see, on the top picture here, just a lot of fluid in there, which is, fluid and electronics, they just don't mix. So here's just some examples on, what we see on the other side if you identify some, really some punctures and potential fluid ingress. Now what happens if the fluid intrusion sits around for a while? The probe might be fine, and you can get lucky. And so, the top picture is of the connector of the transducer where, fluid got in, dried up a little bit, and, really it didn't cause any catastrophic damage, which is fantastic. And the other is, the handle here on the bottom photo, and you can see just the pitting that has occurred over time because of that fluid ingress and just eating away at that metal. And so, this could be really good news and really bad news. Typically not in between. The good news could possibly be probe works fine, just needs to be cleaned out, and you're off to the races. It's good to go, ready for scanning again. The other is, well, the fluid's been sitting on things for a very long time, and it now has corroded some metal electronics that just aren't salvageable anymore, which could result in a replacement. So, these are things that we look for. I just want to show you this to where if it's not caught early, that, there is a risk of a higher risk of a probe being unrepairable just because of the corrosion properties and just deteriorating the material so much so where there's just nothing to work with anymore during a repair. So T-probe again, the insertion tube. So this is the tube that guides the transducer down the esophagus of a patient, and there can be crimps. These insertion tubes can be replaced, they can be refinished, but what happens? Why is there a crimp in them? And from what we've learned from our customers, sometimes patient can bite down on it. Pretty hard bite force, not super common, but it does happen, causing these indentations to occur right here and right here. Another way it's caused is, sometimes there's clamps used with these transducers, and they just clamp it too hard around the insertion tube, so it squeezes and it crushes it down. And another one that we see surprisingly more often than we'd like, it gets caught in a door jam. So, the T-probe's being carried around a hospital or a healthcare facility, and you're going through a door and the door closes faster than you think, and boom, it catches, the T-probe in a door jam. Again, it happens way more often than we ever thought it would, but hey, it does happen. Why is this an issue? Well, all the electronics and all the wires and all of the steering mechanisms are inside that. So they should be free to move. And now when you clamp it down, now you have tension, you have friction that wasn't supposed to be there. So wires can start to rub together and short. You have the articulation lines that are metal, and now they're really tight against each other, and now they're starting to rub against each other, and even against those wires. So you want to have this insertion tube, corrected to prevent some pretty severe damage in the future. Okay, now we're going to move on to some operational faults. So, these are kind of the things that you're going to see that are failures of a transducer, may be caused by some of the faults that you saw earlier, but these are actually manifesting on the ultrasound system itself. And so, they're two, very related things. Sometimes independent, sometimes you can have a fault that doesn't result in image quality. But, these operational faults that really impact functionality and image quality of the transducer, absolutely are tied to some sort of failure or physical failure of the equipment. Here's an example of color noise in a transducer. We've identified that it is the transducer. Here's what you may see. This could be just color. This is an air scan, as you can see. Color is just kind of flashing through, and in particular, you see, color here that it's pretty clear that it's not even with the rest of the color image, that this is actually induced noise and information that's being transmitted and received that isn't there in the actual scan itself. So this is an issue, and this can be one of two main failures, not all of them. Again, it's all circuits. Anywhere in the circuit that breaks between the probe will cause these issues. So anything from a pin being bent and not having a proper connection to the crystal. But the most common failures here that you would see is damaged lines and crystals. And so, in this particular case, it could be one or the other. Doesn't mean it's not something else. More further diagnostics would be necessary at the component level. But again, something you should be looking for, and something that would require repair, and most definitely a repairable item. And here we have CW noise specifically to a probe. So we know it's not the system, and we have noise that's occurring right here in the top. And then in the bottom, you can see that the noise is actually inverted a little bit relative to the top, where you have these black pieces of intermittent missing information. And so the idea here is that, if it's something where you're flexing that strain relief area of the cable of the probe and you can induce the noise, for sure it's the probe, but you got some wire issues that either chafing together and shorting together when you're flexing, or there's a microfracture on the coax line and it's just stretching and coming back together and causing that noise. If you can't induce it, but it's the probe, then it's likely an intermittent connection in the crystal or the connector itself in the probe. Here, again, we've seen this before, dropouts on the transducer. We know it's a transducer, and here you can see in the air scan, we got this pretty large section of dropped elements, and if we scan a phantom, you're going to see that it's just missing all of this information. So again, if we were flexing the strain relief cord area and this goes in and out, so the information is correct and then it disappears on the image, you likely have some line issues. But if you can't do that and you can't induce that type of reaction from the transducer, you're looking at a connector or a crystal issue. Here we have just some pretty catastrophic error codes, specifically 005 and 007. And what this typically means is that there is just a circuit that carries high voltage in this probe. They all don't carry high voltage, but some of them do. And that is, shorting to something else. It could be shorting to another high voltage circuit, could be shorting to ground, could be shorting to, to anything that's inside the transducer to another wire. So just a variety of things that can happen. And the short could be just, chafing of the wires together over time, or it could even be some sort of fluid intrusion where, one drop of fluid will actually short, dozens and dozens of wires together. And if they're not properly sealed, can cause an instantaneous short and cause some pretty serious damage. So the one thing to really be careful around these types of failures is the idea that because it's a high voltage line, this can actually go damage the ultrasound system itself. So when the probe is shorting on its own, it actually can cause a short all the way through that transducer select port into those high voltage boards in this particular case an acquisition module, and cause damage. And so this is why it's so important on these specific high voltage failures, pull that transducer from service as quickly as you can, because the longer you try to use it, the more vulnerable that system is to actually suffering also from this short in the acquisition module, which ends up frying your acquisition module as well. Other times transducers just don't run, and you can see here that this is an example of a fault when a transducer, you're trying to engage it. The moment the machine tries to fire all those relays to get this probe running and start sending power, boom, you get this error message. Obviously, we're trying different ports. We've identified it's the probe, and this can mean several things. First and foremost, the probe just doesn't run. It's just not going to run, and the machine just spit up an error and says, hey, there is something massively wrong with this. This is not just an image quality issue. Like there's a circuit here that is really out of order, and I can't run this probe. And then from an electrical perspective. And so, this could be, an over voltage error. It could be transducer not recognized. It could happen during runtime. So, sometimes probes get over temperature and, they just throw an error. And, a severe short, some critical circuits, or some of those critical circuits, they're open when they should be shorted, like, maybe a high voltage power line. So the probe just can't turn on. So these are, this is an example of a error that's catastrophic, and the probe needs some sort of repair or service to get that thing functioning again. So let's talk about the importance of OEM crystals and lines. And lines are the wires that are really the connecting circuits between the crystal assembly and the connector that eventually connects to the ultrasound machine. And unfortunately, we have to have this conversation because the industry is now being flooded with probes that look completely normal, but on the inside, they are not. And an example here is the industry kind of coins the term of OEM versus non-OEM, and this is absolutely critical for crystals and lines. Now, as we can see in the picture that we have, the non-OEM on top, you can see just the build quality, and we can start from the right here. The crystal just isn't constructed in the same way. It is a hard PCB, and I will mark the hard PCB here, relative to the OEM down below. It's all flex circuits to allow for some maneuverability and some less rigidity, and by the design they just last longer with these specific transvaginal probes that we're looking at. You can see that the shielding on the non-OEM is just basic copper tape, and then you have the grounding from the crystal soldered to the copper tape. Now, from an electrical perspective, yeah, it may work. It's not something we do. We don't like it. We do not use non-OEM crystals and lines. They just don't. We found that they just don't give the image quality. They don't last. But that's just our opinion. We're taking the safe and conservative route. We're going to put all OEM crystals and lines in your probes that we repair because it's best for the patient. If it was one of our family members or somebody that we love, we want the best gear scanning them. And the OEMs, they're doing a great job of building some really great imaging equipment, especially in ultrasound, to take care of all of us. Now, as you can see, we start walking down to the left of the probes. You can see how the termination of the wires, it's the workmanship, the craftsmanship is something that to the naked eye does not look, or from what we found with our customers, it just doesn't hold up. With this really interconnect by an OEM, where that's gonna really be solid and last the intended life of this transducer. And so what are the risks? We kind of talked about it. The lines can be more brittle. So the inferior lines that we are seeing in these knockoff transducers or counterfeit transducers, they're not of the quality of the OEM, and they fail more frequently or causes more repair because they fail more frequently, which really escalates the cost of total ownership for you, the healthcare facilities. And so we don't want you to kind of get stuck in this vicious cycle of it's a cheaper probe or it's a cheaper repair, because some repairs, companies will take the non-OEM stuff and put them into your probe because your OEM internals have failed and it's masked as an OEM probe. And so now you get kind of stuck in this vicious cycle of, why does a probe keep failing over and over and over again? Well, that's a leading indicator. If there's non-OEM stuff in there, it just isn't built to last, just to be quite frank, from our opinion. You know, now you look at the non-OEM crystals. You know, these crystals can operate off frequency and give an inaccurate image. And so there's been cases where you're scanning a phantom, and if you look at, you know, some of the targets, and you can see, let's look at this circle, that circle can actually look slightly oblong, and it's not a perfect circle. So it's operating off frequency. You know, either the sender or receive, we're not sure, but something is wrong, and it's just not a risk that we're willing to take for our customers on who we support. And then there's also been a case where the biopsy guides just don't fit. So biopsy guide is typically a contraption that clips around the transducer, and then a biopsy is kind of indexed off of that for a sonographer or a user or a technician to actually do a biopsy with a transducer and guide it with the ultrasound transducer. Well, some of the non-OEM casings out there are not a perfect shape, and the biopsy guides literally just don't fit. They just won't clip on around it, and it's rendered unusable for biopsy. And now the healthcare facility, you're stuck with this clone transducer that doesn't do what you're supposed to. You may have gotten a good deal on it once, but keeps getting reserviced or needs to be constantly replaced. And the frequency of that occurring is really a new service call every single time. And so just all the soft and administrative costs that goes into a repair service for you to send them out to a repair company, replacing it, you know, really absorbing time of procurement and the engineers. Most of all, you're always going to that site, and it could be a lot of windshield time if you have multiple sites, or just now the end user is just getting really frustrated because they keep failing over and over and over for no apparent reason. And so, you know, we just wanted to take a moment to share that, you know, the criticality of the performance of the equipment is in the crystal and the lines, and it is imperative that, you know, we want you to make sure that when you're getting your probes repaired and serviced, that it's got the OEM crystals and lines in there.